Welcome everybody out to this video where I'm going to give you an introduction to the Takt Production System, and I'm going to use this mirror board to do it. I'm super excited to share this content with you. This is never before seen, and hopefully we give you a perspective that will really connect all concepts together as we go through this free Takt University course that can be shared by and used by anyone. The Takt Production System, as designed by Lean Takt, is really a combination of all lean systems that we could get our hands on, whether it's location-based scheduling, line of balance, Gantt chart, CPM, production theory, lean tools, lean theory, and putting it into a system that is ideal for production. So welcome to the world of Takt. Takt is a scheduling system that maps flow through rhythm, continuity, and consistency on a time beat or takt, through zones with time on the top and location or the value receiving unit on the left. The system stabilizes the project so you can optimize it. It's made on one page, which is key. We can't overlook that. Everybody can see it, showing all three types of flow in construction. The system allows you to level work and create buffers so you can absorb interruptions, variations, and delays. It pairs with Last Planner perfectly and beautifully to involve the trade foreman, and it creates the backbone of your production system and the alignment of all project resources. Takt is the central theme of all lean scheduling systems in construction. So you can think of it kind of like it being the rhythm, or in a sheet of music, the beat, right? Takt is the beat. So I like to think about that sheet of music whenever I'm thinking about the Takt Production System, and thinking about the superintendent and the general contractor really being the orchestra or the choir conductor, right? Keeping the trades on rhythm. Now the trade partners are the experts. They are the ones who know how to play their instrument. They are the ones who know what they're doing, and it's the general contractor's job to keep everyone on rhythm. And that's a very reasonable request. And so when I see pictures like this, where we have the general contractor leaders coordinating and organizing all of the other trade partners to be in a rhythm, I really like it, because trades cannot be good individually unless they're good together. So it's easy to be good, it's hard to be good together, and that's the general contractor's job. So the superintendent is there to make sure that the rhythm is being followed, and the foremen are the experts. And one thing that I want to say is that a foreman is the senior most worker on the crew, but a superintendent is not the senior most foreman. A superintendent is not supposed to be the senior most foreman. The superintendent is supposed to be the rhythm keeper. So a superintendent should ideally love the Takt Production System, because all construction schedules, meaning all construction production plans, should be formatted like this, with time on the top and location, meaning X, Y, and Z, on the left. As we learn in Interstellar, that's really where you get your four dimensions. It's X, Y, Z, and T. And when you get this format, meaning time by location, you're able to see if trades are flowing in this diagonal, which is the single most important consideration in everything that we do in construction scheduling, because that diagonal flow line, that line of balance, with all of the trades going together the same speed, the same distance apart, is the fastest way that the construction production plan can be accomplished. And so that is your rhythm. And we at Elevate and Lean Takt believe in what's called the integrated production control system. That's where you have the first planner system that really plans the project, the Takt Production System, which sets the rhythm and helps you to recover from delays, and then the last planner system, which everybody knows about, which involves the trade foreman. And so let me go through these one by one. The first planner system is really designed to bring the team, the plan, the supply chain, and the culture together to enable work to happen at the work package, so that all production systems can work together to eventually build the product within the zone. The Takt Production System is the simulation and execution of your production system on site. And again, once you've planned it over here, you have this diagonal line which keeps the trades in a flow zone by zone. And it enables other production systems to align to that rhythm. And the Takt steering and control methods enable us to properly deal with delays, deal with constraints, and remove roadblocks out ahead, because it's a nimble system and it maintains your trade flow. And the last planner system provides the environment to coordinate sequences collaboratively with the trades, which enables trades to collaborate on, commit to, and execute a weekly work plan with other trades, and look ahead planning to make work ready by identifying and removing roadblocks in advance. So as you can see, the first planner system is here to literally design the project. The Takt Production System is here to keep us on a rhythm and recover from delays and impacts. And the last planner system is here to make sure that we're involving the trade partners. This is easily done in the time by location format. And so what I figured I would do is go ahead and show you that format. The intersection of time and space is what's called a takt. And the space on the left is typically broken out by program, project, phase, area, zone, or microzone. So there's a lot of flexibility there, right? So the project is obvious. The phase has its own unique zones. Areas are really print areas or functional areas. Zones are the actual production spaces inside the Takt Production System. And microzones are there if needed, if you want to get into a smaller amount of detail, or if you want to increase your production even more with a different standard space unit or standard time unit. Now, one of the things that I really like is this concept of macro, norm, and micro. So the macro level takt plans will always be formatted in a 5-day takt time. And you might ask yourself why, and that's a fair question. It's by week, not including the weekends, so that the team can strategically see the plan and so that we have a nice base. The human mind is really good at understanding how much work will fit into a week, so it's a really good starting point. But this is a visual schedule format that's used in pre-construction planning. The norm is your day by day. This is where you do your production planning and then filter out your look ahead plan, your weekly work plan, and your day plan. And since a day in construction is the typical standard time unit, this is the most ideal norm level format. And then you have the micro level formats where, if you're doing shipbuilding or if you're doing certain types of renovations or whatever the case may be, or civil work, you can go down into the hour by hour, minute by minute in the micro. So that's by minute or hour. The bottom line is that when you see it in a time by location format, you have the intersection of time and space where you see how much work fits in that zone size according to a certain takt time. And this enables us to see everything that we need to see. So let me take you to a brief concept here. There's two different types of takt plans, essentially. There's the single train takt plan and then a multi-train takt plan. Or you can have what's called takt time-based takt planning. There are people that are very rigid about this, right? So there are some softwares and takt practitioners and philosophers that believe everything should fit within a takt time. So this means that it's going to be wagon-based and you're going to prioritize a standard takt time. A multi-train takt plan is mainly resource-based, and so I call it resource-based takt planning. So it's mainly task-based, and we prioritize resource efficiency a little bit more than we do the standard rhythm on a takt time. So what this looks like here in this first scenario is that when you actually see a train of trades, that's what we call them, going through zones 1 through 8 here, all you're seeing in this takt plan, the beautifully cascaded takt plan, is a single train flowing in time. So as the passage of time goes by, you see the movement of the train. That's a little bit different from a multi-train takt plan. If you have the first train and the second train both attempting to go through the same zones, which is fine, you'll see them having different lines of balance typically. And yes, they can fit in to the same overall system and they won't have the same takt time. This is called multi-train takt planning, and there's very specific rules for this which are covered in our books, but I just want you to know that both scenarios are perfectly acceptable in your takt plan. Really, all I want to say is that when you're looking at a takt plan and you see a train of trades flowing through zones, this diagonal shape or the eventual parallelogram is really just us visualizing the movement of the train in time and space. And so you might say to yourself, well, why is that important, Jason? And I'm glad you asked. When you have the time by location format, you can see your bottlenecks. So this really aligns with the theory of constraints, the book The Goal, the book Critical Chain, the books that the entire Goldratt family has written, including Rules of Flow, right? It's not luck. So Eliyahu Goldratt talks about always knowing where your bottlenecks are. So when you have it in a time by location format, you can see trade bottlenecks where you see that is the pace setter on your project, and that's how fast your project's going to go. You also see zone bottlenecks. If your zones aren't leveled properly, you will see that zone number 3 extends, and now we have an inefficiency gap here, just like we had an inefficiency gap there. So one of the things that we can do in the Takt Production System is see our our bottlenecks and then fix them. There are many wonderful strategies you can implement without doing the typical CPM crashing of activities. The other thing I want to talk to you about is rezoning. In the time by location format in the Takt Production System, if you take work like this, where you have trade number 1, trade number 2, trade number 3, with just 2 zones, meaning it's a certain amount of area, certain amount of work, certain amount of labor, and you then take those zones, make them smaller, and instead of 2 zones for the same amount of work, you now have 6. You can see what happens to the work, right? The overall duration is shorter. This is a small example, so it's only by 4 days, but it shows you the overall concept. And it speeds up the phase simply by rezoning it, just by having smaller zone sizes. This is called Little's Law, or the effects of Little's Law. And you might be thinking, Jason, I see what you did there. You're just shortening trade durations. Well, no, I'm not. You see, we have 1, 2, 3, 4, 5, 6, and we have 1, 2, 3, 4, 5, 6 down here. We did not shorten trade durations, but we were able to shorten the overall total phase. This is the magic of rezoning in the Takt Production System. And it's possible because of a couple of production laws. The law of the effect of variation states that you will go faster if you keep on a rhythm and keep things consistency, and that project timelines extend if there's more variation in the system. And so the Takt Production System is great at keeping the pattern rhythmic and maintaining consistency and continuity to reduce variation. Another production law I want to talk about is Little's Law. I've already mentioned it, but the law basically says that if you use smaller zones or smaller batch sizes, you'll go faster. If you level the work, you'll go faster. If you finish as you go, you'll go faster. And as you can see, the Takt Production System complies with all of those requirements. Now let's talk about the law of bottlenecks. Basically, the law of bottlenecks says that because work is organized in processes, right, that you will always have a most limiting factor. And when you find your most limiting factor, it could be a zone that's too complex or trades that are too slow, you can remove your bottlenecks. And then once you've removed those bottlenecks, more will show up. And then I want to talk lastly about the concept of Kingman's formula, which is very loosely translated to construction, but the concept is this, that if you have a duration for a takt time or an overall task duration, it's not just how long that activity actually takes. You have to consider the actual work time, the amount of variation that that crew experiences, and the possible effect of low productivity. And so the other thing that the Takt Production System really lets us do is to zoom in and analyze this and make sure that we have the right balance between the activity and buffers. And one of the things that I love about the Takt Production System is that when you find bottlenecks, you have a couple of options, or problems, you have options. So you've probably heard about advanced work packaging. There's a lot to advanced work packaging, including breaking out these large functional areas, finding the path of construction, using building information modeling, organizing things as work packages, preparing the crew, and having specialists create the installation work packages. But really the concept is this, that we should design, fabricate, and deliver so that we can install properly at the point of work. So instead of saying, hey, we're just going to design this and build it the best we can, find out how we want to build it through the Takt Production System, find out what activities or durations or timelines need to shorten, and then design them differently, fabricate them differently, deliver them differently, and install them differently so that you don't have to push trades to do so. So this is really a reverse approach. Begin with the end in mind. The other thing we can do in this format, which is fantastic, is we have phases where we can pull plan, prepare quality pre-construction meetings, align procurement with a buffer, and then always utilize the last planner system by finding problems 6 weeks out and then confirming our plan a week out. The other thing that the Takt Production System does really well, it aligns WIP. Aligning work in progress is so key because we can't have too much work going on above the capacity of the trade. So I like this freeway analogy. Freeways go fast when the cars are going a consistent speed with a buffer in between them going the same speed and the same distance apart, and when the freeway regulates how many cars can go on the freeway. That's when motorists are going to get to their destination the fastest. Now, what happens if you put a whole bunch of cars on the freeway? It takes longer. What happens if there's an accident and you keep adding cars to the freeway? It takes longer. And so just like adding cars without buffers, not going consistent speeds, will make your travel time take longer, adding too many crews to a project site above needed levels will make your project take longer, especially if there's a problem. And that's one of my biggest complaints about CPM. The critical path method, and I'm not going to dig into this too much here, but the critical path method is genius for increasing work in progress above capacity, disobeying production laws, and disrespecting people. If you look at all of the key parameters that we care about from a production standpoint, when you compare CPM to Takt, you'll see that only allows you to verify your sequence is a maybe in CPM. Everything else is a no. And so in summary, Takt allows you to obey production principles, maintain or align your work in progress, and respect people. But in summary, CPM is a genius system for increasing work in progress, for disobeying production laws, and disrespecting people, which is why I hate it and will be committed to destroying it throughout the rest of my life. And so if you want to learn more about how CPM increases work in progress above the capacity of the system, read Built to Fail, Goldratt's Rules of Flow, or How Big Things Get Done. If you want to understand how the CPM system versus Takt disobeys production laws, you can just look at the keys to lean thinking right here. Lean is about respect for people, stability, and flow through 5S and stable systems, one-piece flow by contractor, flowing together on attack time, seeing together with visual systems and total participation, and then improving together with continuous improvement. CPM does not allow you to respect people, it pushes them. It does not allow you to stabilize, it puts people in a panic. It does not allow people to work in one-piece flow. It puts people everywhere on the construction site. It does not allow trades to flow together. It's not formatted that way. It does not allow you to see it within its 76-page wordy black and white schedule, and it does not allow you to improve anything, which is why the only thing owners can really do is yell and scream and pound their fist on the table when they want their contractors to do better. Everybody in this industry has been abused by CPM at one point or another. The other thing is that CPM disrespects people. People have an inherent right to understand the plan, to have input in the plan, and to not be pushed or hurt by the plan. And so one of the things that I really like to focus on in the Takt Production System is that the Takt Production System was always and should always be about people. The system is designed to respect workers, benefit leaders on projects, and get people home safely to their families. If we ever lose that focus, we don't get it. Takt planning, steering, and control is designed to bless the lives of people. And so here's a warning. There will come a day when Takt planning will produce such remarkable results and become so popular that people with ill or misguided intentions will jump on the bandwagon and try to use it for profits and fame over people. This framework is dedicated to the purpose of preventing that. So I hope that never happens. We have to protect people. And so one of the things that I really like is that Takt isn't just a system or a scheduling system or even a software. It's a way of doing things. So we have checklists that I think you'll absolutely love. One of them is the rules of flow and production planning, which basically say always pre-kit, do not dissolve logic, do not shorten durations, always allow trades to work in a flow, utilize buffers, don't trade burden, always have workable backlog, and always maintain diagonal trade flow. We also have a list of 10 commandments, we also have a list of principles, and we also have a list showing what it means for Takt to be done incorrectly. So if you follow the rules, you'll be okay. We also have resources that I'm pleased to share with you. We have books for every field position that teaches how to integrate inside the Takt Production System. We have videos on YouTube on the Jason Schroeder YouTube channel or the Lean Takt YouTube channel. We have a Takt guide. This is remarkable. When you go here, you really have a framework for how to use the system. We have podcasts on how to use it, too, actually. Miro boards that outline the entire system, and then role boards, meaning Miro boards that showcase each role and how to get education for all three. So really, there's plenty of resources for you to learn the system. And one of the things that I want to do is really close out with this concept of why is flow important, right? Why is building capacity and flowing so much more important than pushing? And I want to take you to a really neat game. This was invented by Lean Communications and HUPS and Lean Takt, and it's a really neat game. And I'll show you how to play it right now. So go ahead and go to the link. And so this is the software, and when you play it, if you maximize it, which I'll go ahead and do here, you'll hear a noise. If you hit M, it will mute that. But I'm going to go ahead and show it to you in the smaller window so you can see everything. Basically what this is this is like a building with multiple rooms. You can hit the commands up here at the top, and then these are trades down here at the bottom. The bottom line is that the computer will do a random roll of the dice. So the dice range is 1 to 6 on each of these. And what happens is when I hit start game and then start rolling, the computer will do a random roll of the dice. So the random dice roll was 5. And 1 to 6 means that there's a high level of possible variation. Then you hit end round and you can hit start new round, so they're ready to go. The computer will go ahead and do the roll of the dice, and you'll see that this first contractor was at a 3, the second one is a 6. So that means this first contractor could have done more, but only was able to do 3. And then you'll see that she has this little warning up here that said, hey, I don't have the materials. And then she has a warning that says zone not ready. So they're being held up. What we can do in this software is do an autoplay and really simulate what would happen here in a 1 to 6 high variation environment. When you get done, and all of the trades are down to the end, you'll see this nice summary here. And so the summary will say, hey, they finished at week 18 with 219 people with an unused capacity total of 51. The Takt plan really went to poo over here, and the X's represent roadblocks. So not ideal. Okay, so let's go ahead and look at what it would happen if we created some more consistency. So what if I increase these to 3 and reduce the high limit to 4? What this basically means is that we're going to spend more time planning and preparing, more time keeping people in rhythm, go slower. But because we have more time to plan and prepare, and because we're focused on a rhythm instead of rushing and pushing and panicking, now we have better certainty and we're not going to roll 1. So let's go ahead and autoplay this and see what our results are. This is pretty realistic. This is what we find on normal construction projects, so this is pretty realistic, and I want to show you the results. So by the time this gets done, I'll go ahead and maximize it and show you that the crews finished in week 14 with 181 people with 13 unused capacity. You can see the X's here where there's still roadblocks, and then the white blank spaces are where they couldn't do work. So not bad. This is typically what we see when we do Takt in the real world. And so let me go ahead and hit escape, and I'm going to hit a new game. Now what I want to do is I want to do something ridiculous. This would never happen in real life, but I want to switch this to 3s. So this means that we're slowing way down below even the average speed, but we're going so slow and spending so much time on pre-planning that literally there's one consistent speed, right? Trades are a little bit mad because they could go faster, but hey, we're going to try this out. So let's autoplay this and see what would happen. So when we autoplay this, you can see there's no problems, no question marks, no impacts. This would never happen, but I want to show you what the effects of this are. And so if I maximize this, you'll see that they finished in week 14 with 168 people with 0 unused capacity with a perfect Takt plan. Now that would never happen, but I promise you this is going to be useful for us to see here in a minute. Now what if I did something really extreme and said, hey, we're going to slow people down to almost their slowest pace? Right? Trade partners are like, I can't do this. I need my people. I'm mad. I'm about to walk off the job. But the crews have so much time to plan and prepare. There's so little variability that they are literally running at a perfect speed. This would never happen, but let me go ahead and show you what this does. So no question marks, no problems, no impacts, and we are auto playing through this at a consistent, but it is a slower speed. So let me go ahead and show you what this looks like. So they finished in week 18 with 168 people with 0 unused capacity in a perfect Takt plan. So here's what I want to do. I'm going to do this in front of you. I want you to go to your internet browser and type in theleanbuilder.com. And when you go to their fantastic website, you'll see the blog option. Click on the blog, please. And you'll see this wonderful human being over here, Jason Schroeder. Just love that guy. He just speaks to me, man. I just understand everything he says. Anyway, you'll see this blog post, Why Pushing Doesn't Work, Takt Towers. If you click on it, then we'll go through some information here that I think you're absolutely going to love. Now, when we go through this and the blog post, if you ever want to do this yourself or play this game yourself, we have the actual link. We have an instruction of what the interface looks like. We have an instruction on how the game is actually played, and then we give you some parameters to follow as you're going through it. And then what we do is we say, hey, let's go through scenario 1, where we have a range of 1 to 6, meaning high variability. And you'll see that just like we did in the real simulation, we finished in week 18 with 238 people, 70 unused capacity with a really messed up Takt plan. This is like if we had 10 energy units, meaning 1 through 10, meaning that's like 1 through 10, that's the capacity of the team. The team only has 10 energy units to spend on whatever we're doing. This would be like spending 9 energy units trying to go fast and only 1 in planning and problem prevention. Okay, let's take the second scenario where we had a narrower range of 3 to 4, meaning more flow, less lower variability, but less attempt to go fast, right? We finished in week 14 with 186 people with 18 unused capacity and a pretty decent execution of the Takt plan. This would be like us having 10 energy units but spending 6 of them trying to go fast and only 4 trying to prevent problems and plan out ahead. Okay, now let's go to the unrealistic one of 3 to 3. This would never happen, but I wanted to show you what would happen. If we do that, we're at 168 and 0 with a nice Takt plan finishing in week 14. This would be like spending only 3 units of energy going fast and 7 trying to plan and prepare and prevent problems. Then I took you through the last one, which was the dice range of 2 to 2. We finished in week 18 with 168 people, 0 unused capacity, nice Takt plan. This would be like only spending 1 energy unit trying to go fast. We're really not trying to go fast at all, and spending all of our focus on planning and problem prevention, right? Now here's the point. This is where it really gets impactful. The data aggregation is where we learn our lesson. You'll see over here in this row and in this column overall that we have the dice range of 1 to 6, 3 to 4, 3 to 3, 2 to 2, right? These two are pretty realistic. This is pushing, this is flow, this is like fantasy land. But check out what happens when we show the amount of weeks that it took for them to finish. The total labor on the project, we're just using a really low wage of $36 per hour, not even burdened, right? At, I believe we did 40 hours a week. And then we calculate the labor cost. Look what happens. Pushing, meaning that we're trying to go fast, but we hit roadblocks, finishes in week 18 with a lot of people, but it costs a lot of money. When we get more flow, even though it's not perfect flow, we finish in week 14 with 186 people, and we have a pretty decent labor budget. Okay, when we do the 3 to 3, which wouldn't really happen, I want you to notice that we're at 168 and 3.3 million, but it's not a whole lot different than the real flow, the real things that we see on construction projects. So even with a little bit more labor and a little bit more cost, they're not much different. And then check this out. When we did the unrealistic 2 to 2, which is way slow, we finished in week 18 with 168 with 4.3 million. So what I take from this data aggregation is that even if we did the silly thing, which we would never do if going really slow, you still finish in the same amount of time and it's still cheaper, and adding more people does not get the project done faster. It just costs you more money because you have workers waiting on work standing around. More people does not equal more productivity. What we learned from this, and I'll take you down here at the bottom, is that when we have a problem, please remove roadblocks, reduce the effect of constraints, bring out materials just in time, keep a consistent rhythm. But do not throw labor at the problem, add excess crews, throw money at the problem, rush large amounts of materials to the site, and make workers work too fast and too long. There's a huge difference between flow and pushing. And so one of the things that I want to talk to you about is that I have zero respect for pushers. I'm a driver. A superintendent driver is one that works with the team and drives with urgency. Pushing is doing the stupid things of throwing labor at the problem, throwing money at the problem, making workers go too fast. Building capacity and flow is where you make work ready. So pushing is like rolling 1s and 6s. Building capacity and flowing is like rolling 3s. We've included this in here with pictures of everything, the actual link to the blog post right here, and the data aggregation if you ever want to play this game with your people on site, and some recommended reading. Really what I want to say is that at the end of this is that the Takt Production System includes Takt Planning and Takt Steering and Control. So Takt Planning is where we really plan the project with flow. Takt Steering and Control is where we see problems and recover properly. And I hope this gives you a really nice overview of how the Takt Production System can help you specifically by aligning work in progress, obeying production laws, and respecting people on a fundamental level. And so this is the introduction video. I hope to see you on the next one in this series, and I hope you've really gotten something out of it and that you will actually avail yourself of the resources and this wonderful free Miro board that we're giving to you. On we go.